For millennia, humanity has gazed at the stars, wondering, are we alone? Is Earth truly unique, or are there other worlds, far beyond our solar system, where life could exist? The search for habitable planets is one of the most profound scientific quests of our time. We now know that planets orbit nearly every star in the universe. But among the billions of exoplanets, how many could truly sustain life? Could there be Earth-like worlds teeming with alien ecosystems, waiting to be discovered? For centuries, this question was purely speculative. But in the last few decades, our ability to detect and study exoplanets has exploded. Thanks to revolutionary telescopes and space missions like Kepler, TESS, and the James Webb Space Telescope, we are now on the verge of answering the age-old question. Are we alone in the universe? But what makes a planet habitable? What are the conditions necessary for life? And how do we even begin the search in the vastness of space? This is the story of humanity's search for another Earth. A journey through time, science, and the boundless reaches of the cosmos. Join us as we uncover the greatest cosmic mystery of all, the search for habitable planets. The idea of habitable worlds beyond Earth is not new. For thousands of years, humans have looked to the heavens, wondering if other planets, perhaps even other civilizations, exist among the stars. The earliest theories, from myth to science. The ancient Greeks were among the first to suggest that Earth might not be unique. The philosopher Democritus, 5th century BCE, speculated that countless worlds must exist, each potentially home to life. Later, Epicurus wrote of infinite worlds scattered across the cosmos. But for most of history, these ideas were mere speculation. The dominant belief, rooted in geocentrism, was that Earth was the center of the universe, and everything revolved around it. Everything changed in the 16th and 17th centuries. Nicholas Copernicus proposed that Earth was just another planet orbiting the Sun. Galileo Galilei's telescope revealed moons around Jupiter, proving that not everything revolved around Earth. Johannes Kepler mathematically described planetary orbits, laying the foundation for modern astronomy. But the most radical idea came from Giordano Bruno, an Italian philosopher who argued that the stars were suns like our own, each with planets of their own, some possibly inhabited. His ideas were considered so dangerous that he was burned at the stake in 1600. The birth of modern planetary science. By the 19th and 20th centuries, astronomers began to speculate more seriously about exoplanets, planets beyond our solar system. In 1961, Frank Drake developed the Drake equation, a formula estimating the number of potentially habitable planets in our galaxy. However, no actual exoplanets had been found. They were still invisible to telescopes. Some scientists even doubted they existed at all. That skepticism persisted until the 1990s. The first discovery, 51 Pegasi b. Everything changed in 1995 when Swiss astronomers Michel Mayor and Didier Queloz made a groundbreaking discovery. 51 Pegasi b, the first confirmed exoplanet orbiting a sun-like star. 51 Pegasi b was a hot Jupiter, a massive gas giant orbiting extremely close to its star. It was not Earth-like, but its discovery proved that exoplanets were real. From that moment on, the floodgates opened. Telescopes around the world began detecting hundreds, then thousands of planets beyond our solar system. The search for habitable worlds had officially begun. With the discovery of the first exoplanet in 1995, a new era of exploration began. But finding a planet is only the first step. The real challenge? Identifying worlds that could support life. Scientists use multiple techniques to detect exoplanets and determine their potential habitability. These methods have revealed thousands of distant worlds, some eerily similar to Earth. Keycap 1: How we find exoplanets. Telescope: the transit method. Watching planets eclipse their stars. One of the most successful methods is the transit method, used by missions like Kepler and TESS. This technique detects tiny dips in a star's brightness as a planet passes in front of it. Kepler's legacy. From 2009 to 2018, NASA's Kepler telescope revolutionized our knowledge of exoplanets. It discovered over 2,600 confirmed planets, and provided statistical proof that most stars have planets. Kepler revealed the first Earth-sized planets in habitable zones, sparking hope that we may find a true Earth 2.0. Cyclone the radial velocity method, detecting the wobble of stars. Even if we can't see an exoplanet directly, we can detect its gravitational influence on its parent star. This technique, called the radial velocity method, was used to find 51 Pegasi b, the first known exoplanet. It works by analyzing a star's Doppler shift. As a planet orbits, its gravity tugs the star, causing its light to slightly shift toward red or blue. Radial velocity is especially useful for detecting rocky planets in close orbits. Future missions aim to combine this technique with direct imaging to reveal even more details. Milky Way direct imaging, capturing exoplanets with high-tech cameras. The ultimate goal is to see exoplanets directly. This is extremely difficult because planets are millions of times dimmer than their parent stars. However, using adaptive optics and coronagraphs, astronomers have successfully imaged gas giants orbiting far from their stars. Upcoming telescopes will enhance this technique to image Earth-sized planets. Keycap 2: What makes a planet habitable? Finding planets is one thing. Determining if they can support life is another challenge entirely. Scientists look for three key factors when assessing a planet's habitability. Globe showing Europe, Africa, the habitable zone, the Goldilocks region. The habitable zone is the region around a star where temperatures are just right for liquid water to exist. Too close? The planet is scorching hot, like Venus. Too far? The planet is a frozen wasteland, like Mars. Just right? The planet could have oceans, rivers, and the potential for life, like Earth. But habitability isn't just about distance. Other factors like atmospheric composition and magnetic fields play a crucial role. Cloud atmospheres, the key to life. A planet's atmosphere determines whether it can support life. Thick atmospheres, like Venus, trap too much heat, creating a runaway greenhouse effect. Thin atmospheres, like Mars, can't retain heat or protect against radiation. Earth's atmosphere has the perfect balance: oxygen, nitrogen, and greenhouse gases that regulate temperature. New telescopes like James Webb can analyze exoplanet atmospheres, looking for signs of water vapor, oxygen, and even methane, potential indicators of life. Volcano geological activity and magnetic fields. A geologically active planet is more likely to be habitable. Volcanism recycles carbon dioxide, helping regulate climate. Meanwhile, a strong magnetic field shields against deadly solar radiation. Mars, for example, likely lost its atmosphere because it lacked a strong magnetic field, making it uninhabitable today. Keycap 3: The most promising candidates for life. Over 5,000 exoplanets have been confirmed, but only a handful are potentially habitable. These planets lie in the habitable zone and show signs that they could support liquid water. Waterwave Proxima b, the closest potentially habitable planet. Located 4.2 light-years away around the red dwarf Proxima Centauri. Orbiting in the habitable zone, but may be bombarded by intense radiation. Future missions, like the Breakthrough Starshot project, aim to send nanoprobes to explore it. Ring planet Kepler 442b, one of the most Earth-like worlds. Found by the Kepler Space Telescope, Kepler 442b is 1,200 light-years away. Slightly larger than Earth, with a high chance of having liquid water. If it has an atmosphere, it could be one of the best candidates for life. Globe showing Europe, Africa, TRAPPIST-1 system, 7 Earth-sized planets. Visual: a planetary system orbiting a dim red dwarf, multiple Earth-sized worlds in view. A remarkable discovery: 7 rocky planets, 3 of which are in the habitable zone, located only 40 light-years away, making it a prime target for future study. These planets could have liquid water, depending on their atmospheres. Keycap for the search for alien life, the next big step. Finding habitable planets is exciting, but the ultimate goal is detecting alien life. Scientists use a method called biosignature detection, searching for chemical signs of life in a planet's atmosphere. Potential biosignatures include oxygen and ozone, produced by life on Earth through photosynthesis; methane, can be produced by microbes, unnatural gases, CFCs, industrial pollution. If detected, they could indicate intelligent civilizations. The James Webb Space Telescope, along with future observatories, may soon provide the first real evidence of life beyond Earth. We are now at the frontier of one of the greatest scientific discoveries in history. Thousands of exoplanets have been found, and new worlds are being detected every day. But despite our progress, major challenges remain in the search for truly habitable planets, and even more so in the search for alien life. KeyCap won the cutting-edge tools of discovery. Today, our most powerful space telescopes are pushing the limits of what we can observe. The search for habitable planets is being led by three major missions. Telescope James Webb Space Telescope, JWST. Launched in 2021, JWST is the most advanced space observatory ever built. It can analyze the atmospheres of exoplanets using infrared spectroscopy, detecting possible biosignatures like water vapor, oxygen, and methane. JWST's first observations of exoplanet atmospheres have already revealed carbon dioxide on WASP-39b, marking a new era in exoplanet research. Satellite TESS, Transiting Exoplanet Survey Satellite. Designed to scan the entire sky, TESS is finding thousands of new planets. Unlike Kepler, which focused on distant stars, TESS looks for planets closer to Earth, where future missions can study them in detail. Satellite Future Missions. The next generation of exoplanet hunters. The Nancy Grace Roman Space Telescope, launching in 2027, will use next-gen optics to find Earth-sized planets around Sun-like stars. The LUVOIR and HABEX space telescopes, proposed for the 2040s, could directly image habitable exoplanets, giving us our first true glimpse of an Earth-like world. KeyCap 2. The biggest challenges in finding habitable worlds. Despite rapid advancements, scientists face major hurdles in identifying planets truly capable of supporting life. Milky Way distance, the vastness of space. Most of the promising exoplanets are hundreds or thousands of light-years away. Even Proxima b, our closest candidate, is 4.2 light-years away, a journey that would take thousands of years with current technology. Without faster propulsion methods, actually reaching these planets remains a dream for the distant future. Globe showing Europe-Africa atmospheres, a key factor in habitability. Many exoplanets exist in the habitable zone, but that doesn't mean they can actually support life. A planet's atmosphere determines if it's a paradise or a lifeless rock. JWST is beginning to analyze exoplanet atmospheres, but we still need better tools to detect oxygen and other biosignatures with certainty. Comet the hostile nature of space. Many habitable zone planets orbit red dwarf stars, which are unstable and emit violent solar flares. Planets like Proxima b may be constantly bombarded by radiation, stripping away atmospheres and making life impossible. KeyCap 3. The Great Filter. Why haven't we found alien life? Even if habitable planets exist, one question haunts astronomers. Where is everyone? This is the heart of the Fermi paradox. If the universe is filled with habitable worlds, why haven't we found evidence of extraterrestrial life? Some possible explanations include: life is extremely rare. Even if planets are habitable, the chance of life emerging may be much lower than we think. Life is common, but intelligent life is rare. Simple microbes may exist, but complex civilizations like ours could be extremely rare. Advanced civilizations destroy themselves. Some scientists believe that intelligent life inevitably self-destructs through war, resource depletion, or environmental collapse before reaching interstellar capability. We're looking the wrong way. Alien life may not be carbon-based, or it could exist in forms we can't yet detect. Some scientists believe that within the next 20 to 30 years, we will have the technology to answer this question once and for all. Scene fades to black, setting up the final section, the future of the search for habitable planets. This section explores the current state of research, the biggest scientific challenges, and the mystery of why we haven't found alien life yet. We stand at the edge of one of the greatest discoveries in human history. In the next few decades, we may finally answer the question: are we alone in the universe? The search for habitable planets is entering a new era, driven by next-generation telescopes, advanced AI, and even interstellar probes. What will the future hold? KeyCap 1, the next wave of space telescopes. Future missions will provide sharper images and deeper insights than ever before. Telescope, the James Webb Space Telescope. First steps toward an answer. JWST has already begun analyzing exoplanet atmospheres. Within the next 10 years, it could detect the first real biosignatures, proof that an exoplanet has conditions suitable for life. Satellite, the Nancy Grace Roman Space Telescope, 2027 launch, will use powerful coronagraphs to block starlight and directly image planets. Could be the first telescope to capture a true image of an Earth-like exoplanet. Telescope, the Louvre and Habitable telescopes, 2040s, the holy grail of exoplanet science. These super telescopes will be powerful enough to study planets in detail, detecting weather, surface conditions, and even vegetation from light years away. If Earth 2.0 exists, these telescopes may be the ones to find it. KeyCap 2, artificial intelligence and machine learning in exoplanet hunting. As we collect massive amounts of data, AI will play a key role in analyzing exoplanet atmospheres and identifying habitable worlds faster than ever before. AI can detect patterns in starlight fluctuations, identifying potential exoplanets more accurately. Machine learning models are already helping astronomers determine if a planet's climate is stable enough for life. As AI improves, we could soon scan entire star systems in minutes rather than months or years. KeyCap 3, interstellar exploration, the next leap. Finding habitable planets is only part of the journey. The ultimate goal? Traveling to them. Rocket, the Breakthrough Starshot project. This initiative aims to send light-powered nanoprobes to Proxima B within the next 50 years. These tiny spacecraft, traveling at 20% the speed of light, could reach Proxima B in just 20 years, sending back real images of the planet. Satellite, the future of space travel. Scientists are exploring nuclear fusion propulsion and even warp drives, concepts that could one day allow us to reach other star systems in a human lifetime. If these technologies become reality, the search for habitable planets could turn into actual interstellar colonization. KeyCap 4, what happens if we find an inhabited planet? The biggest question of all. What if we detect life? If we find simple microbial life, it will confirm that life is common in the universe. If we find intelligent life, it could redefine humanity's place in the cosmos. But there's also risk. Should we try to contact alien civilizations? Some scientists warn that revealing our presence could be dangerous. For now, we continue to search. But with every discovery, we come closer to answering the greatest question in science. For centuries, we have gazed at the stars, wondering if we are alone. Today, we stand on the edge of discovery, closer than ever to answering one of humanity's greatest questions. The search for habitable planets has transformed from ancient speculation to a scientific reality. We now know that planets exist around nearly every star, and many of them may have the right conditions for life. With powerful new telescopes, artificial intelligence, and future space missions, we may soon find the first Earth-like world, a place where oceans ripple under an alien sun, where life, perhaps intelligent, thrives beyond our reach. But what happens next? Will we discover microbial life? Will we find evidence of alien civilizations? Or will we be faced with the unsettling realization that we truly are alone? No matter the answer, one thing is certain. Our search is only just beginning. The universe is vast, filled with countless worlds waiting to be explored. And as long as we continue to reach for the stars, we may one day find another home among them.